I'm Dragan Savic, representing the Water Distribution Systems Analysis History Project. The purpose of this project is to document the history of water distribution systems analysis, and an important part of it is a series of interviews with practitioners, modelers, researchers, engineers who have made significant contribution to the field of water resources and water distribution systems analysis. Our interview today is with Paul Sage, who had a varied and interesting practical background in water distribution systems modeling, ranging from working for a research institution and then working for a large water utility in the UK. This interview is being conducted on the 3rd of September in Leicester, UK, during the Computing and Control for the Water Industry conference. Paul, much of your work has been done working for a large utility, and I was wondering if you can give us an overview of your career and involvement with water distribution systems modeling.
I'd like to start by just reflecting on my 30 years or so in the water industry. As Dragan says, much of the last part was with a large corporate water utility in the UK. But before that, it was with the Water Research Centre, where I was a user of an early network model, WhatNet. In those days, I think it's useful to reflect on the history. A large model was 500 to 600 nodes. And we built the models by wearing slippers, walking over OS maps laid on the floor of somewhere like a community centre. And so we artificially skeletonized the models as we built them. They were entirely demand driven. Demand was for domestic properties was via postcodes, and so we also had a calibration threshold, which is critical, of plus or minus 1 metre. We aimed to succeed in simulation by getting good matches at minimum night flow, average day demand and peak hour demand, and to add a bit more depth to the process, we often used to use an alternative mode in which people would open various boundary valves, and that gave more sort of feeling to the outputs. So that was the early days. And then, having joined the large corporate entity, the advent of GIS came about, and about, I would say, the mid-90s, and that's when there was a sea change in network modelling from the previous sort of simplified approach to the all-mains approach using GIS. GIS wasn't always correct, but nevertheless we used it, and so the models became much more detailed, but we still used a demand-driven approach, and we still calibrated by a trial and error process, changing pipe roughnesses to achieve reasonable simulations, but within a plus or minus 1 metre threshold. Moving on, early after the millennium, it was by then pretty commonplace for large numbers of district meter areas to have been set up, and the perception was that modelling was going to get easier because of all of this control being put into the systems. At the same time, as the DMAs were in place, we saw the beginning of further pressure reduction as child areas in the DMAs. These discrete pressure areas, or pressure managed areas as they were called, were located where topography of the ground was low enough to permit further pressure reduction, or to keep leakage to within agreed targets with the regulated industry strictures. So that was fine, but it was becoming apparent that something more was needed, and I then happened to attend CCWI in 2005, where I met Dr. Zen Wu of Bentley Systems, and we started talking about possibilities of using optimization methods in their products. And we set to and tried this out. And we had a good first result in so much as we found a very large leak in the study area from an already calibrated model in the traditional way. But there were clearly a lot of other problems. And so the next step was to try and build a model where we opened hydrants in the middle of the night, so in a controlled way, so we measured the flows out, and this was really picked up from Dr. Tom Wolsker's work in the United States, where there was attention to trying to get pipe roughness values for the mains. There was a lot of concern about doing this in the UK. There was great fear of the modelers ending up causing the company lots and lots of discoloured water complaints. But on that point, we'd been supporting the work carried out at Sheffield University on pods and looking at the distribution of discoloration from material being sloughed off the pipe walls in times of high flow. And we were able there to use that to, let's say, mitigate those threats of discoloured water. So we were allowed to go ahead with this novel testing technique. And that's when the issues got really interesting. We couldn't find any leakage hotspots to start with, but that was later identified. The reason for that was there were some unknown closed valves in the system, and one of those was found and identified on site, and then that was corrected in the model, and we tried the optimization process again, and we found that a fabricated leak we'd also set up by cracking open the hydrant was identified, and that was a great moment. We realized that there might be something in this. Although I think in the literature it had already been mentioned that optimization might be an iterative process. And so time went on, and what's happened in recent years is I've had the opportunity to work with Exeter University and Severn Trent Water, who are the primary industrial partner. I'm just the junior. I've since retired from the large corporate life and set up my own little business. And we're now looking at what we've called the new generation of network models, and absolutely fundamental part of that, there are two key things. Leakage is being treated as a pressure-driven demand, which is what it is, and indeed it's what the whole of the smart network approach and pressure calming approach, which is widely being deployed throughout the water industry, is all about. And the other point is the coarse calibration. Pressure transducers are now accurate at 0.1% full-scale deflection. That means we should be able to get within 0.1 of a metre readily. And so we are taking advantage of the new technology that's come into the pressure transducing side. And so from initial work, which the research student presented at CCWI on the 2nd of September, yesterday, it's beginning to look as though there is some real useful work going to come out of this process. So I hope that helps answer the questions. Thank you.
Related to that, you've given us this whirlwind tour of your activities. Can you give us an overview of your understanding of the usage of network modeling in practice in the UK?
I think it's seen as a exercise which has always been done now, and there's a need to maintain them. But I think that the modelers are having difficulties now meeting the new sort of requirements from the operational side of the business. I think in the past it was much more about planning, and the modelers fulfilled that role quite well. But now, in terms of supporting operations, real-time model, real-time control and so on, there needs to be a big change in the approach to the whole subject area. And that's why I see the need for the academic side to team up really with the industry to start really to help the industry out of a potential problem area it's getting into with the fact that the models aren't delivering as well as they could.
That leads me to the next question. You mentioned quite a few universities and researchers involved with you and developing these methods. Mm-hmm. Can you tell us a bit more on the interaction between the industry and academia, where the problems are or where the advantages are in terms of creativity and getting new results?
I think it's a question of having the enthusiasm to make it work. I think there's sort of in the industry, as long as people are delivering what they're being asked to deliver, and if you like, ticking the boxes, that's the job done. But whatever we see now, we're still losing nearly a quarter of our water in the UK, and that's not a sustainable position to be in. So we have to pull in people who have the skill sets and the gifts, if you like, to be able to work on these systems, which then have to be kind of made into a form that the regular network modeler or technician can use. And I think it's vitally important, not just in the UK, but worldwide, in terms of water strategy and water scarcity.
That leads me again to, you just mentioned 25% of the water lost on average. What is the future for modeling and systems analysis? What do you see as challenges for the next 20, 30 years?
I think the challenge is to bring this, what's possible in academia into the water owner operators' businesses as business as usual. And it's got to be worldwide. I think there are some issues with intellectual property which are quite difficult, in that as a modeler, if you use a proprietary product, the sort of ideas and concepts you may have from the work you're doing will tend to be automatically owned by the commercial software providers. Now, I think in that view, the new initiative for EPA Net 2 is excellent, so I would hope that would start answering some of the issues. Does that help?
Yes.
Yes.
Paul, can you tell us a little bit more about security of the system, cyber security as it's normally called, of these SCADA systems that are being used prevalently now within the UK water industry?
Well, yeah, I mean that's a concern. That's a concern. Quite understandably, the owner-operators are very nervous about information about their water mains network being made publicly available. So I think there has to be an understanding between academia and the businesses about how they can collaborate without, publishing for academics is important, and but security of systems is sort of on the other hand for the water owner operators is really important as well. So there has to be systems put into place whereby people can still communicate and collaborate and also publish work, but anyone who of a mischievous disposition is not going to be able to use that information to go around causing detriment to the systems and that sort of thing. So I think that came up from the session this morning, and I think yes, it's a really important point to understand how we manage that in the future.
Thank you, Paul.
Thank you.
Thank you very much.